This video is for review quiz P.6, and this one's all about rational expressions or fractions with polynomials in them and how to simplify them. So this first one, we have y squared plus 2y minus 35 over y squared plus 9y plus 14. And so what we're going to do here is we're going to simplify this thing down, and we do that by factoring the top and the bottom. There's a couple things we have to do in this, but the first step is always kind of factoring everything. So for the top portion, we see we have 1 and 1 for a on both top and bottom. But for the top, a times c is 1 times negative 35, and b is 2. So two numbers that multiply to give the top, add to give the bottom. It's going to be 7, positive 7, and negative 5. So the top thing, because a is 1, we can do the shortcut for the AC method. The top thing just becomes y plus 7, y minus 5. The better you are at factoring, the faster these will be. All right, the bottom, a is 1 again, so we can use the shortcut, a times c, and b on the bottom. So this one we have positive 7 and positive 2. And we can immediately factor it into y plus 7, y plus 2. Now, you'll see that y plus 7 is on top and bottom, so we will be able to cancel that. Before we do this, we must ask the question, what values of the variable, in this case y, give us 0 in the denominator? The thing we can never do in mathematics is divide by 0. So what values of y make these things 0? In other words, what plus 7 gives you 0? That's going to be negative 7. Negative 7 plus 7 is 0. And negative 2 plus 2 is 0. So negative 2. And we have to exclude those things. After you factor it and before you do anything else, make sure you ask this question. And you always need to ask this question whenever you have a fraction, a division with potential to divide by 0. That's very, very important to note those things. Now we have these two parts and we can simplify this expression. Those cancel, and that gives us y minus 5 over y plus 2. There's nothing else we can cancel here. We cannot cancel the y's. That's because the plus and minus, those tend to lock things into expressions. They can't really be separated from that. So this is the best we can do. And we also know that this is the case. So the first part is, what is it simplified? Y minus 5. And then I'm going to highlight it all to divide y plus 2. And we know that y cannot equal negative 7 and negative 2. Make sure you put a comma between those two numbers. And that's correct. Okay, here we have very similar, except now we're dividing two expressions together. The first thing you'll always do, just like when you do it with fractions, is you never divide by a fraction. You always multiply by the reciprocal. And the reciprocal is the second thing. So I'm flipping the second term, and I'm not writing the division. So this is what the problem is actually. It's multiplying by the flipped the second. Okay, now we can do the same process we did the last time. Factor everything, ask what values give us 0 in the denominator, and then we can continue from there. So we can take out a 5 from this top term, but we can't do anything else there. Giving us 2x squared plus 3. This is a prime. You could try using the AC method, but you're going to see that this is prime. Nothing will get us what we want. This is a difference of 2 squares. This is the same thing as 7 squared. And so this one factors down into x minus 7, x plus 7. This bottom thing, I can take out a 3 from it, giving me 2x squared plus 9. And now I can ask what values give us 0 in the denominator. So we can see that this one right here has an x plus 7. And so we know that 7 minus 7 gives us 0. So x cannot equal 7. This one, 2x squared plus 9. The question is when does that equal 0? So we subtract 9. Then we divide by 2. And we're asking what squared gives us negative 9 over 2. And nothing squared gives us negative 9 over 2 unless you're doing a complex number, which we're not interested in. So this will never give us 0. So we don't have to worry about that factor. Now there is only one more thing that we have to consider. If you were to continue this problem and only have this as the answer, you'll get it almost correct. But in the original problem, this problem right here, you'll see that we have a fraction of x squared minus 49. This was in the denominator before we flipped it. And so we must consider when does this thing give us zeros? Because if it did give us a 0, we'd have a division by 0, division by that. And it just gives us a division by 0, which is never allowed. That's the same thing as asking when does this top portion, because x squared minus 49, this is the same thing as this, which is the same thing as this. This gives us 0 when x equals 7, which we already have, and when x equals negative 7. So we have to also have negative 7. Again, that's because this has, it is in the denominator in the original problem. So we must consider that thing. Once you do that, you can flip it and you can continue as you normally would. So now we can cancel like terms. Those cancel. X minus 7's cancel. And we are left with 5 times x plus 7 over 3. And that should be our full answer there. X plus 7 over 3. And then 7 and negative 7. Check it. And that's correct. Very good. Okay, here's another simplification. All we're trying to do here is, again, simplify everything down. So x cubed minus 25x over 6x squared. 2x squared minus 2 over x squared minus 6x plus 5. And as this division, I can rewrite this as multiplication by the reciprocal. So 7x plus 7 over x squared plus 5x. Now, we're going to have to consider both of these things as being in the denominator, as well as these two things as well. So we'll have to consider all that stuff after we factor everything. This first one we have, I can take an x out of here, giving me x squared minus 25. And this is a difference of two squares. It's going to be x minus 5, x plus 5. So the first thing we get x times x plus 5 times x minus 5. The denominator has nothing. It's just a monomial. There's nothing we can do with that. This one I can take a 2 out of there, giving me x squared minus 1. X squared minus 1 is a difference of two squares. So I get x plus 1, x minus 1. And the denominator, this I can use the AC method. A is 1, 1 times 5 is 5, and B is negative 6. Two numbers that multiply to give 5, add to give negative 6 is going to be negative 1 and negative 5. And since A is 1 here, I can immediately factor it into its parts. Okay? 7x plus 7, I can just take an x, a 7 out of that. That gives me 7 times x plus 1. And the bottom thing here, I can just take an x out of there, giving me x plus 5. Okay, everything is factored, and now I can ask the question, what x's give me zeros in the denominator? So starting with what we have here, we have a 0 here will give me 0. X can't equal 0. A 1 here, a 5 here, and a 0, which we already have from this one, and a -5 from this one. And like I said before, 7x plus 7 was in the denominator originally. So we must consider, when does this thing give us 0 as well? Because it was the same thing as this. And that happens when x equals -1. So -1 is also included in that answer. So you can see automatically it's going to be B. B has all those parts. Now we can cancel like terms here. Excuse me. We have an x and an x. We do it in red here, x plus 5 and an x plus 5, x minus 5 and x minus 5. What else we got? X minus 1 and x minus 1. And this 2 and a 2 and the 3. That looks like everything. So let's write down what we have left. On top we have a 7 times x plus 1. On bottom we have a 3x squared, and that's it. So that's what we have, and it is incorrect. Let me see if I made a mistake here. And I made one simple mistake, and I missed the x plus 2 here. There's an x plus 1 here and an x plus 1 here. That all that changes is that there's 2 x plus 1s in the top. And I put a squared there, and that gives me the correct answer. So that's all I did, is I just missed the fact that there's 2 of them there. And the rest of it is correct, though. Okay, this one we just need to subtract the 2 expressions. We have 3x over x squared plus 4x minus 21 minus 2x x squared plus x minus 12. And the way we subtract fractions is we get common denominators. The only way we can know if they're common denominators is if we can factor them. So factoring is once again the method we're going to do here. A is 1, a times c, and then b. This is going to be positive 7 and a negative 3. A is 1 here, so we get a times c and b. This gives us positive 4 and negative 3. So factoring this all down, we get 3x on top, 2x, x plus 7, x minus 3, x plus 4, x minus 3. Again, I can immediately factor this thing down because a is 1 in both of these. As long as you have that, the shortcut method works out nicely. Okay, so after we factored it, we must take note that x cannot equal negative 7, 3, negative 4, and this one's also 3, so that one's already taken care of. We have to take note of this, and we can immediately see that it has to be a, because b doesn't have negative 7 in it. Okay, now to subtract these fractions, we must have common denominators. In other words, we can ask, what does this one need that this one has? This one has an x plus 4, so let's give it to the other one. We do that by multiplying top and bottom by it. This one needs an x plus 7. And now you see they both have the exact same factors in the denominator. That's a very quick way of doing it when you have everything factored. It only works if you have everything factored. So make sure you do that step first. Okay, 3x, x plus 4, minus 2x, x plus 7. I can combine them into one fraction because they have the same denominators. Now I can simplify the numerator down. So distribute the 3x, distribute the negative 2x, gives me 3x squared plus 12x minus 2x squared, 14x. Leave the bottom factored. We're gonna have to factor everything in the end anyway, so that we can cancel common factors. So just better to leave it all factored in the bottom. So now we combine like terms, and we have 3x squared minus 2x. That gives us x squared. 12x minus 14 is negative 2x. It's still over the same denominator, so it's going to be x plus 4, x plus 7, and x minus 3. Now I can factor the top. I can take out an x from both of these things. That gives me x times x minus 2 all over x plus 4, x plus 7, x minus 3. And we can ask the question, is there anything factor from this? And it doesn't look like there's any common factors on top and bottom. So our answer will be this thing by itself. X minus 3. See if that's correct. And it is. All right, we got another one where we are adding and subtracting. X minus 3 over squared plus 5x plus 4. So these second two fractions cannot factor at all, so we're going to leave that the way it is. The first one, however, can. X squared, so a is 1. 1 times 4 is positive 4. Positive 5, that gives us plus 1 plus 4. Which means it can actually factor to x plus 1 and x plus 5. Once you have a factor, there's really no reason to go back to the original expression there. So just leave it like that. Now we can ask the question. This is 4, not 5. We can ask the question, what zeros, what x values give us 0 in the denominator? So we have negative 1 gives us 0, negative 4 gives us 0, negative 1 again, and then negative 4 again. So we know x cannot equal negative 1 or negative 4. Definitely going to be A, negative 1, negative 4. And we can continue factoring everything, or simplifying it all down. This one needs an x plus 4. This one needs an x plus 1. Okay, this first one we haven't done anything with. So write it down. Next one is going to be negative x plus x3, negative 3x times x plus 4 plus 1 and x plus 4. And the last one is going to be 2 times x plus 1 over the same denominator. And all of them have the same denominator, so I can combine them and subtract and add the numerators as necessary. So we have the first thing, minus 3x times x is negative 3x squared, minus 3 times 4 is negative 12x, then plus 2 times x, plus 2 times 1. Okay, now I can simplify everything down and then ask if I can factor it. So we have a 4x squared, 3x, and is there no x squared in that one? No, there's not. Then we have a 10x, a negative 12x, and a 2x, and finally a negative 3 and a 2. So we have 4x squared minus 3x is x squared. 10x minus 12x is negative 2, plus 2 is 0. So the blues cancel. And negative 3 plus 2 is negative 1. And this is a difference of two squares, therefore it factors into x plus 1, x minus 1. And you'll see the x plus 1's cancel. So we have x minus 1 over x plus 4. And that's correct. Okay, this is called a complex fraction. And a complex fraction is just a fraction within a fraction, which is not nice to work with. So we're going to do something to make it no longer complex. And we do that by multiplying everything by the least common denominator of everything. So this 3 is the same thing as 3 over 1. And this 1 is the same thing as 1 over 1. So the least common denominator of everything is x. I can multiply this thing by x over x, multiply this by x over x, and you'll see everything will have x in the denominator. But I don't need to do that. I'm going to multiply everything by the least common denominator. And so that distributes. So on top we have 3 times x is 3x. X times 1 over x is going to be 1. X times 1 is x. And x times 1 over x that's negative there. Negative 1. And now you see I removed the fraction within a fraction. And this is easier to work with. Now I will notice, you should note that x cannot equal 0. If it does, we have a 0 division here. We also need to notice that x cannot equal 1. If it does, this would be 0 here. So there's two layers of possible for zeros in the denominator. So make sure you're checking both of them. Check the original problem, and then check the problem when you simplify it down. And this thing cannot be simplified any further. That's the best we're going to be able to do. So let's see if that's correct here. Top we have 3x plus 1, x minus 1, and we have 0 and 1. And that's all correct. All right, this last one's an interesting problem. It's a complex fraction, but it's actually a very special complex fraction. And that's because it is the basis for what's called the derivative, which is a calculus concept, which is an instantaneous rate of change. And this is the formula that you would use for a special one, namely 7 over x squared. We're asking what is the derivative of this thing? That's the idea for this. Now, it's not all there, but this is kind of the main work of it that you have to do. And this is just a complex fraction. We have two variables, but that's not really an issue here. All we're trying to do is make it so that's no longer complex. And we can do that by making everything have 0 in the denominator. Now, first off, we need to note that x cannot equal 0, because if x did, this would be 0. And h cannot equal 0, because if it did, this would equal 0. And as long as x and h are both 0, this thing won't be 0. Everything else makes this thing non-zero, so there's nothing we have to worry about here. So we have to note those two things first. Now we can simplify this thing down. I'm going to do that by giving everything at least a common denominator. Actually, this is actually easier. All we have to really do is make the top have common denominators, because then we can deal with the bottom. H is the same thing as h over 1. On top here, we can multiply the first thing by x squared and the second thing by x plus h squared. That gives us this is just h over 1. And now we have two fractions that are dividing. So I can rewrite this as multiplication times by the reciprocal of the denominator, which is that. Now I can simplify it all to hopefully get something that can cancel. And on top here, we have 7x squared. X plus h squared is going to be x plus h times x plus h. I'm going to leave the denominator factored. Times by 1 over h is really just having an h in the denominator. So now I can expand this numerator, giving me 7x squared. It's going to be minus 7 times x squared plus xh plus hx. That's just going to be 2xh, and then h times h is h squared. Try it out yourself to convince yourself that I'm correct there. And then negative 7 distributes into everything. The denominator is still there. X squared, x plus h squared. Okay, and now you can see that those cancel. And I can factor out of here a negative 7h. That gives me 2x plus h over h x squared x plus h squared. And these h's cancel. That gives us negative 7 2x plus h over x squared x plus h squared. And this is the best I can do. These things in parentheses are not like terms, so I cannot cancel them at all. And there's nothing else in common there. So it looks a little weird, the final form. But we're missing one thing here, and that's called a limit. And if we had that, we could do a couple more things, and it would actually end up being nicer to work with. But this is the kind of the main work of it to find what's called the derivative, like I said in the beginning there. So let's see what we have. Select the correct choices below. Let's see. X and H. This one has no numbers for X. This one has no numbers must be excluded. This one says no numbers must be excluded for H. But we do have one for each. We have that X and H can both not equal 0. So we need to have those two things. And the simplified form, fraction in there, negative 7 2x plus h x squared x plus h squared. Hopefully this is correct, but this is probably really easy to get wrong. Okay, let me figure out what I did wrong here. Okay, so I found the error, and the error happens because x cannot equal negative h. This is the only thing I added there. Everything else was correct. That's because x plus h, I didn't think about this before, but x plus h squared cannot equal 0. If it does, we have 0 in the denominator here, or right here. So to make sure that it doesn't do that, we first need to make sure x does not equal 0 and h does not equal 0. If they both did, then we'd have 0 squared, which is 0. And we must also include that x cannot equal negative h. If it did, we would have negative h plus h squared, which of course is 0 squared, which equals 0. That also must be included. This is the same thing as saying h cannot equal negative x. It's either one. As long as you have one or the other, you should get this thing correct. So I just put x cannot equal negative h. If I check my answer now, it is correct.